me reiterate. And recording in progress it is. So, yeah, this is our second session, so welcome to session two. A quick reminder from last time, next Friday I will not be available due to a conflict of interest. So our next meeting will be in 2 weeks on July 5th. So please bear this in mind, no meeting next week. Once again, this is not in any way affiliated or sponsored by Stanford. This is like Vicky and me, and I'm putting Vicky in front because she's doing all the hard work. She's doing all the all the dirty work,
That's
and
not
I just
true. I just need to chime in here because if you didn't sign up to do this,
right.
none of us could do this without you. And so just leave
Sure.
me out of it.
But I was just telling Vicky that vice versa works as well. Without her, I would not have been able to do this. But still, yeah. So hats off to both of us, and please be aware that this is not graded, certified in any way. No attendance taken. We don't care. We only want people who are here for fun and learning, and that's it. So we're doing this every Friday at 12 p.m. Pacific time. Well, this time that we're here right now. Vicky very seriously asked for this link to not be shared anywhere publicly because this is her link. So please do not share it on social media, Discord, WhatsApp, Telegram, whatever you use. Please don't. The main format that we do is that we ask you to watch the lectures and attempt the problems before we meet. So the idea here is that you should be prepared and not, because I'm not going to be covering the theory. I'm going to go through the problems and explain the problems in case there is a number of people who failed with a certain problem. Also, we had last time the conversation about switching sections and judging from several people writing things in the forums. The section switches have been made. So all people that wrote to Vicky and asked for the switch to be made, it's been made. The only problem is Cameron, the head TA, he said that there are 6 people who requested the change, but he does
That's
not.
all solved now. Okay.
That's also okay. No
Yes,
problem.
that's
So then
all solved.
I was
Basically everyone who's actually wanted to change has been
changed.
changed. Okay.
Okay. Okay. Good enough.
If there's like other people who are new and wants to change sections, I can't promise it. Just email me and then I'll talk to Cameron. And then Alex, just wanted to let you know there's like now 28 people. So you lost.
Well, but that's including you and me, so it's 26.
Okay, whatever. I'm sure by the end of the hour you're still gonna.
I have no chance. I know that. So yeah, I'm not even gonna come. I'm not gonna even going to react anymore to your barbs. Um, so we are also recording these meetups, and we will be posting them on the main forum, and they will be active for 1 week. After that, they will be deleted to conserve space. So if you do not want to be in the recording, if you care about not being in the recording, then at least I'd ask you to turn off your video. But on the other hand, I'm quite happy to see live people and not black squares. So thank you to all of you who turned on your cameras. It's a lot more pleasant to work with real people and not, black rectangles. So also a couple of words about next time we meet, because the next topic that we're going to cover is strings. And the problem with the topic of strings in the current Code in Place site is that there are no problems for strings. And Vicky took a look at the previous years, 2022, and found problems specifically for strings. So we will share. My only question is, Vicky, I have no idea how will we share the links, because like showing them on the screen is quite useless.
Right. So basically, what I will try to do, okay, I can't promise I will be able to do it every week. I may forget. But what I will try to do is I will try to share the video and whatever code that you go through in these sessions. And then along in that email, I will also list
The links.
like what we'll be covering the following week.
Okay.
And so Alex, that means, okay, like you need to tell me before the weekend whether you approve of the topic and the problems.
Okay, well, for this one, I approve. Like
Right.
Alexander Belikov approves of this topic. It sounds like a political, this message is approved by the whatever. Yeah, so then this will go out through email, and there is a link to one of the lectures, and there is a link to a number of problems that we ask you to try to solve, and we will deal with those problems next time we meet in 2 weeks. So I think that's that in terms of general conversation, and let's now go um, to the two problems that we had for tonight. We had the topic was information flow, and really it's not that much of a topic, but like it's important to understand how it works. But my question to you, just let me 1 more second, I'll share the screen again with my code in place site. So the two problems that we had was FizzBuzz and Breakout. And FizzBuzz is obviously a lot simpler than Breakout, which requires a lot more getting into it because it has graphics and what have you. So my first question is there anyone who wants to go through FizzBuzz as a problem? Does anyone have any questions on that one? Because if everyone managed to solve it, I don't see the point in spending time on it. But if someone has questions, then I'm more than happy to spend a couple of minutes on this problem. So you can reply with voice, you can reply in chat, whatever whatever is better for you. Yeah, Tracy, I see you're saying you don't need to go through FizzBuzz. I'm certain a lot of people don't need to go through FizzBuzz because, yeah, I think many people solved it. But still, if someone needs some help, then I'll just wait for 20 seconds, see whether anyone goes like, I need help from FizzBuzz. If not, then
Alex,
we'll go to Breakout.
why don't you just spend like 5 minutes going over it? Because I feel like I was always the one in class that was afraid to speak up because everyone else seems to know what they're doing. And so if there's somebody else who's afraid to speak up, just take
Okay,
time.
okay. Sure. I think that's fair. That's fair. It won't take much time. How do I suggest to follow lectures? When you say lectures, Leah, do you mean this meetup? Because, okay, that's a good question. You can surely try and code along, and see how it works for you. Yeah, I don't have another, because the second option is not to go along and just listen to me, but obviously going along is probably more helpful than just listening. So if you're able to do it at my speed, Vicky asked me to try going a bit slower so that everyone sort of is on the same page. I will try to slow down a bit maybe
Please,
today.
could you make your screen a little bigger?
You mean the text on the screen? Let me see. I probably would be able to. I need to find the.
Control plus or something like this, yes.
Would this be enough? I made
It's
it a bit.
better.
Okay, let's try it like this. Yeah. So let's take a look at FizzBuzz first. So the goal of FizzBuzz is a rather silly game. where you get a number. In our instance, we have a constant which is called max value, which is set to 17. And we need to, in this game, count from 1 to this number. So here it would be from 1 to 17. And each time we hit a number which is divisible by 3, we need to say fizz. If it's divisible by 5, we say buzz. If it's divisible by both 3 and 5, we say fizz buzz. In all other cases, we just repeat the number. So it would be 1, 2, fizz, because fizz is divisible by 3, 4, buzz is divisible by 5, fizz divisible by 6, 7, 8, then 9, again fizz, 10 is buzz, until we reach 15. 15 is the first number which is divisible by both 3 and 5, then it would be 30, 45, whatever would be fizz buzz. So this is the task, and we do this in the console. So what we have right now is the main function, which it says here modify the main function, so it prints every number from 1 to max value. And since we want to do the same thing over and over again for a number of integers from 1 to max value, this is a good place to use a for loop. So can someone help me out here and tell me what the for loop should be if we want to go from 1 to the maximum value which we have in a constant? You shall not pass. That's good. Next time I should wear a white beard and a wizard hat and pretend to be Gandalf. I'm not old enough to be Gandalf, but yeah. So, any thoughts on how we would do this for loop? If we want to go through all the numbers from 1 to the maximum value we have in the constant. Once again, you can print it in the chat, or you can speak. It's faster if you talk.
For I in range 1, comma, max value plus 1.
Why do we need the plus 1?
Because it will go, if you don't have a plus 1, it will just go to 16.
Yeah, that's important. So I see Chiara saying for I in range max value. If you do I in range max value, you will actually get from 0 to max value minus 1. We could do it the way you're proposing, Chiara. So it's not a mistake. We could do it like this. Well, the only mistake is it has to be capitalized because it's a constant. But then inside you would have to add 1 to I each time. So instead of from 0 to max value, it's from 1 to max value plus 1. So it's easier for me to do it the way Priscilla said, from 1 to max value plus 1. But yeah, your proposal is not a mistake. It's just a different way of doing the same thing. So, and inside, what we have to do is call this function, which is called fizzbuzz, and we'll need to write this function with the number. So instead of calling with 1, we will pass I as the argument. So each time inside the loop, it will be a different number. And here we first save the result of calling this function into a variable, and then we print that variable. But since this is like math, we have to say here, we have to say here, we can actually take this function call and put it inside the parentheses and save ourselves some memory. We do not need this variable. This will give us the exact same result. First, the function call will resolve into a value, and then this value will be printed. So now what we need to do is actually write the fizzbuzz function itself, and we're done, basically. So the fizzbuzz function takes in a integer, and depending on a number of conditions, this integer will return, the function will return either fizz, buzz, fizzbuzz, or the integer itself without any changes. So what are the conditions that we need to check here? Help me out. What are we going to use to decide on the output of this function, on the return value?
If it's divisible by 3 and 5, is it divisible by just 3, or is it divisible just by 5?
Yeah, super. And yeah, I see Abhinav, you wrote the same as code in the chat. Yeah, it's very important to make the first condition, whether it's divisible by both 3 and 5. Because if you do it otherwise, you will never get fizzbuzz. You have to first check the more compound condition and then check the simple conditions. So yes, the first thing we do if n is divisible by 3 and n is divisible by 5, in this case, obviously, we print fizzbuzz. We know that this is a number like 15 or 45 or 300, whatever. Then we would do an elif and check these two separately. We would say, otherwise, if it's only divisible by 3, we print fizz. Oh, sorry, we're not printing it. My mistake. We're returning it. We actually have to return the value. And then we do not need elif. We can do a simple if, because if this condition is true, the function will end with the return word. It will never reach this condition. So we can do if. We can do elif. It doesn't really matter. So if it's divisible only by 3, we return fizz. If it's divisible only by 5, we return buzz. And in all other cases, we return the number itself, the integer itself. The only thing that bothers me in this function is that here we're returning strings, and here we're suddenly returning a integer. And it's bad form to have a function return different data types in different situations. So I would, since we're printing it, I would probably return it as a string as well, just to make the return value uniformly string in any condition. So this is the entirety of the program. So if we launch it, you will see that we got everything from 1 to 17. And here we got our fizz, our buzz. At 15, we got fizz buzz. And if we change this to, let's say, 100 and launch it, we'll see, obviously it's wrong, but we'll see this is 15. Then we here, this is 30, this is 45, and this goes down to, I think, 90. Yeah, we have 90 here. So it all works. And 99 is obviously fizz divisible by 3. 100 is buzz because it's divisible by 5. So this is fizz buzz. This one is rather simple, but the idea here is that you have a function which gets a parameter. So you send an argument here as a parameter, and then you return the result of this function, what this function does. You return it back to the calling program. And I guess the reason why it was written like this, to actually show you that in order to save the result in your main function, you actually have to, save it to a variable. Because otherwise, if you simply do this, if you simply call the function without saving the result anywhere, you will get an error because this will not be, this variable will not exist. It will not be initiated. So we need to save the result somewhere and only then print it. So I think we're done with fizzbuzz. Let's go to breakout. And my question to you is, like last week I asked you, can you give me a plus in the chat if you finished breakout, if you actually got it to work the way it's supposed to work, or give me a minus and, sort of explain where you were unable to, where you got stuck. Maybe you say, I got stuck on the, the first or the second step or the third step, whatever. So at least I understand the level of trouble that we're having with this problem, because it's obviously a lot more complicated and difficult than the first one. Okay, so I am aware that Nate managed to do this. We actually had a bit of a back and forth on the subject, and we had some ideas of what more we could do with the with this code. Yeah, Vicky, I know that it nearly killed you. You had to call 3 friends, and none of those friends were me. You spared me. But yeah, we'll check it out. Getting overlaps to work properly. Richard, when you're saying overlaps, you mean like the ball hitting one of the bricks. Do I understand correctly? Yeah. Okay. Okay. And there are different ways of doing this. Like in most programming assignments, except for the simplest ones, there are always different ways. There will almost never be two programmers who have the same solution to a problem. I know this because I teach kids at school, and when I see identical code, I immediately know that that code was copied from somewhere, because it's almost impossible to have the same code for a problem written by two different people. The last condition of both sticking to the paddle was very poorly written. I couldn't replicate it as well when I wrote it. It's quite hard to do. The reason why it happens, though it all depends on how you do it, is that sometimes if the ball hits the paddle on the side, it will actually get stuck inside the paddle, and so it sort of goes like blah, 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 and then it flows back out. But it depends.
Alex, the way to do that is just to slow it down. Is to increase.
Oh yeah, that's a good idea.
When I did that, it was cool. I could see it happening. And that's when I made the correction.
Right. Yeah, thanks for the comment, because that's actually a simple thought. You can actually slow it down, but I did not. For some reason, I did not come up with it. I tried for about a couple of minutes to actually do it at normal speed, and then I sort of went like, who cares? So yeah, we can try doing that tonight. So I see a number of people giving pluses. Do I understand that the rest simply did not attempt the problem, or that you are just shy, saying that okay, in progress? So some of you are in the process. Okay, so spoilers ahead. There will be spoilers. We will be solving this problem tonight. Yeah, the code in the forum. Okay, yeah, I got it. Someone spoiled it for you already. Okay, so let's take a look. Basically, Breakout, I didn't actually know that it was Steve Wozniak's game, because the one I played back in the 80s was called Arkanoid, and it was probably an older version of the game. I remember it very vividly. I still remember the music from that game. I mean, it's like 40 years ago. Well, not 40, maybe 35, but I can still play the music in my game, the game music in my head. It was so addictive. So the idea is that for this specific problem, we have a very specific setup of the world, because in the real game, you have very different setups of bricks. They are situated in different variants. This one is the simplest one. It's actually the first level. And the idea is that you have a number of rows, you have a number of columns, and we can see that each row has a different color. So the first thing we need to do is actually create these bricks. And for these bricks, we have some constants. So what we have here at the moment, we have the size of our game board or playing field, whatever you have it. So we have a width of 500 pixels and a height of 600 pixels. So this one is here. And we have some sizes. We know the height of the brick. So the height is going to be a base 10. And we have the width. And the thing is that the width is actually calculated as a function of the canvas width. So what it's saying here is that let's take the entire width and sort of divide it by 10, but before we divide it by 10, we take out 9 gaps between the bricks. Well, because if you have 10 bricks, you have 9 gaps between them. So if you subtract those from the width and then divide it by 10, you sort of get the the size of the brick. But what I do not like about this solution is that the number of bricks is actually hard-coded. That's one of the things we discussed with Nate. And I propose to change this immediately. I would use a constant which would be called bricks in row, and for now I will set it to 10. So here then, it would be bricks in row -1, and here it would be bricks in row. And then we would be able to use this, which one is it? We would be able to use it for any number. I would just have to change this number, and we could have a world like 10 by 5, 10 by 10, 10 by 20. We just need to change a single number here. So that's the beauty of using constants in your code. You change it in one place, and your program immediately, changes it everywhere where the constant is used. So now, how do we approach this first step? The description of the problem here is sort of notoriously, it's not well written. I think there were some changes to the constants after they wrote these instructions, and they did not change the instructions, so it's a bit, wishy-washy. So the idea here is that we're going to break the main function into a number of sub-functions or helper functions to make our code more readable. And yes, Adina, you're saying the instructions are a bit inconsistent with the starter code. Like I said, my feeling is they first wrote the instructions, then changed a bit the code, but forgot to change the instructions. So yeah, a bit messy, but we have what we have. And one of the questions is, for instance, how far away should the top bricks be from the top of the canvas? Because it's not shown anywhere. I mean, we can see here that there is a space here, and in the original game there is also a space, because you can actually bounce the ball into this area and it will go on a killing spree, going like dun 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 dun, destroying the upper bricks. But there is it doesn't say this anywhere, and I watched like Chris's implementation, and I noticed that in his code the height was different from the one here. So I just picked a number. I said, let it be 50 pixels. It's going to be 50 pixels away from X. And the way I would propose doing this, like I said, there are different ways this can be done, but basically what we have here is a matrix of bricks. So we have a two-dimensional field of bricks. We have rows, we have columns. It's like an Excel table. And the way you work with two-dimensional objects, where you have to, for instance, draw them on a canvas, we could use a loop. We could use a loop and iterate over the rows. So we would have a loop of 10 iterations, and in each iteration we will be drawing one row. So the first iteration will be for the first red row, then the second one for the second red row, the third one for the first orange row, and so forth until we have all 10 of them. But inside this loop, we could have another loop. So it's a nested loop, because if you need to draw 10 bricks in a row, it's a bad idea to like write 10 lines. You would launch another loop inside the first loop, and that loop would be responsible for drawing the entire row one brick at a time. So this is the first thing we're going to do, and we will do this in a function. So let's call it, I don't know, let's call it create bricks or something. And let's pass our canvas as the argument, because we are going to draw these bricks in this function. So our function is called create bricks. And let's do the loops. So the first loop is going to be vertical. So I will use the y coordinate. I will say instead for I will say for y in range. And my guess is that we will always have 10 rows. So this number, we could do like we could do number of rows. And we also do 10. And then we say for y in range number of rows. And then inside this loop, we do a nested loop, which would be a different one. So it's important to have this indent here, because this way you show that this loop is inside this loop. And here we would write x, because this loop, the inner loop, will be responsible for the x coordinate. And here we would say for x in range, and we have bricks in row. So we have the second variable, the constant, sorry, the second constant. So, okay, we have y, we have x. What do we do with them? We are going to be doing two things at the same time. The first thing we're going to be doing is we're going to create a list of objects of these bricks. And the second thing we're going to do is actually draw those bricks on our canvas. So in order to create a list, I will first create an empty list. So I will have a list of bricks. The only difference, I'm not going to do it here. I'm going to do it here before I start iterating inside the loops, because I need only one list, obviously. And now, inside this inner loop, the iteration of the inner loop, I will actually draw something on the canvas. If I remember correctly, I constantly go back and forth between Pygame and graphics. Please remind me, is it create rectangle? Is it draw rectangle? What's the name? Create rectangle, thank you. Is it like the full rectangle or rect? I think it's full rectangle, right?
The whole word.
Okay, yes, thank you, Vicky. So the first thing we are passing, if I remember correctly, the coordinates of the top left corner and then the coordinates of the bottom right corner. Am I correct here?
Top left and the top right. I mean the left right. The left y.
Top left
corner,
bottom right.
The left corner and then the bottom right corner.
Yeah. Okay. Cool. And then the color. The fifth one is the color. The coordinates. How do we calculate the coordinate of the top left coordinate of the brick? But we have to remember that this brick can be anywhere, horizontally and vertically. Can someone throw in an idea for me? How do we understand, depending on where the brick is, what the coordinate of the top left corner is?
Well, for me, because I did it in the more general case, I had a variable called side gap.
Okay.
Get into a constant. And then, so for the upper left x, it was side gap plus, see, I used I, you used, for the inner loop, you used x. So
X, yeah.
X times the brick width plus the brick gap.
Okay. So basically, in our case, yeah, you would have those in parentheses.
And in our case, in our case that we're doing, the gap would be 0 because that's how they set it up.
Well, no, actually, they have a brick gap of 5 here.
No, I mean the left and right gaps.
Oh, right, yeah. In our case, since the way it's calculated at the moment, the brick width means that it takes up all the bricks take up the entire space. There is no side gap, so we're doing this at the moment without the side gap. This is the thing in the instructions that sort of bothered me. So yes, in our case, we take the to calculate the x coordinate, we take this x and we multiply it by the width of the brick plus the brick gap. So if it's 0, because the first one is going to be 0, that means x is 0. For the first one, we take the width of this brick and the width of this gap, and we have our, for x1, we have this coordinate. For x2, we sort of take 2 widths and 2 gaps, and we end up at this coordinate. So this works for whatever we have at x from in our case, from 0 to 9. And the same thing works for y. with the only difference that instead of brick width, we use brick height. The gap is the same, so we have the same vertical and horizontal gap. There is no difference here. And we also need to put here the distance we want from the top of the canvas. So we can actually do this as a constant as well. We call it distance from top, and let's set it for 250 for now. And here I will put it here, like distance from top plus whatever we get here. And this way, using x and y, we will get the coordinate of the top left corner of the brick. So this will be brick x. This will be brick y. Hopefully I'm not screwing this up. And in order to get the bottom right corner, we need to just take brick x and add the brick width. And in order to get the bottom y coordinate, we need to take brick y and add the brick height. Let me quickly see the chat. Yeah. And after this, we need to put in the color.
Please correct in the 31 line, brick height.
Sorry, one more time.
Brick height spelling 31 line number 31.
You misspelled instead of height, you said high.
Sorry.
Height.
Okay. Thank you. Yeah. Thank you. Is brick height? Yes. I would have received the error. But you are better, error checkers than Python itself. So thanks. So now the question becomes, what do we do with colors?
Alex, I have
Y bricks in row -1. Just a second. In 17, because the number of gaps is always one smaller than the number of bricks. So if you have 10 bricks, you have 9 gaps between them. This is the classic fence post problem. You have one less gap than the bricks. So that's why we are subtracting 1 and only, okay, you got it, super. So what do we do with the color? Any ideas of how we actually implement the color depending on what row is? Any fresh ideas?
Putting in the list of the colors.
Okay. When you say list, do you mean just put them in order? And okay, Adina, I see your idea. So you can integer divide by 2, and then you would get the index of the color that you want to use. And actually, in this specific instance, I like that idea very much because it's very quick, it's very simple. So excellent idea. I will propose a different solution, not because I think that my solution in this case is better, but I think it's more generic in terms you could use this idea in other situations. But like I said, I like the one we have right now. I would propose using a dictionary in the following way. I would do a dictionary called colors. And for the dictionary, I would use indices as the key. So for instance, I would say for index 0, we have red, and for index 1, we also have red. And then I would do the same for all the remaining indices that we have here. Like for 2, we have, orange. For 3, we will also have orange. For this specific problem, it's a bit more cumbersome. So I would stick with your idea with the list specifically for this one. I'm just showing alternate solutions which could be helpful when you actually do not have this mathematical equation to work with. For instance, if I said, I want my first 4 rows to be red, and then 1 yellow, and then 7 green ones, and you cannot solve it mathematically. In this case, dictionaries are a lot more flexible. But once again, I am not taking from your, I think, very, very nice idea. I love your idea. So 6, 7 would be green, and 8 and 9 would be, is it cyan? I was actually never sure. How do you correctly pronounce this? Do you pronounce this in English cyan, or is it pronounced differently?
It's cyan.
Cyan, okay. Because sometimes, you know, when you never pronounce the word, but you read it, you sort of, like in English, you have no idea how to pronounce it. Like there is the word disciples. I was always certain that it's pronounced disciples because it's like discipline, discipline. Why is it disciples? I still have no idea. English is very unpredictable.
The word hors d'oeuvres is also a tricky one if you only read it first.
Right, right. Okay, so what does 1 divided by 2 get you? The idea is that if you have the index, like for indexes 0 and 1, integer
sorry to
division.
interrupt. Can we use the keys name as red, orange, etc. instead of 0, 1?
You use what here?
Red.
But what's there is a very specific reason why I'm using numbers, because here
Okay.
I'm going to do this.
Oh.
I will use x, and that's it. Because I have in this variable x, I go through 0, 1 until 9, and this is all I need in order to get the necessary number.
Oh.
Yeah, okay, you got my idea now.
Yes, yes.
Okay, excellent. And so the last thing that we need to do, we actually need to save this brick into our list of bricks. So first of all, I need to save this into a variable. So now I have an object which is called brick. And this is actually object-oriented programming. So the thing that I'm getting here is an object of a certain class, which is probably a class of rectangle. Would it be y instead of x? Yes, it would be y. Thank you. Thank you, Anna. It would be y because this depends on the row and not the column. It actually would have looked quite different. We should check it out and see how it would look. But yes, good catch. I should have said that I did it on purpose just to see whether you're paying attention, but no, I just screwed up, and thank you for helping me out here. And now we need to add our brick through append to our list. And at the end, the last thing we need to do, this is important, we need to return the result of our function. And here we need to save it into a variable, because otherwise there is no information flow. There is no information flow between the main function and our create bricks function. This is how we get the result back and use it inside main. We return it here, we save it into a variable here. I think this should be enough to actually draw something. No, not enough, because the thing that we need to do, though, hold on, do we? No, I don't think we need to flip anything in graphics. Once again, okay, so we have this, and it does look quite close to what we're supposed to do here. I mean, in this picture, my feeling is that the gaps are a lot smaller, but I mean, we are using the constants which are given to us here, and I think on my screen this is 5 pixels. We can actually try changing it. Let's try changing it to 1 and see if it works. And you see, thanks to our constants, everything changes perfectly. So I just changed one number and I have a different one. Do you want a brick gap of 10? Sure, there you go. You have a brick gap of 10. But how about we change the number of rows? Or well, it won't work with rows. We'll get an error because we don't have enough colors. But let's change the number of bricks in a row. Let's make it 12 bricks in a row. Would that work? And as you can see, it works perfectly. Now instead of 10, we have 12. I can change it to 2, and we'll have 2 huge blocks. So using constants like this gives us a lot of flexibility in what the game world looks like just by changing one single number in the entire program. But let's go back to the initial. I think this is what we're supposed to get. And let me check quickly the chat. Floor division. Yep. And you say yes, you can. And I am not even sure, Adina, what you're saying that to already. I already forgot my question, if it was a question. Okay, so I think we are done with the first one. We have our field of bricks, and we actually have it inside the list that we can work with later. Ah, you're responding to Leah. Okay, no problem. I'm missing the conversation. Oh, I feel so left out. So let's take a look at number 2. We want to add a bouncing ball. And before we add a bouncing ball, I propose we just add the ball. And to do that, we will also create a separate function, which will be, say, ball, create ball. I'm not very original, not very creative in naming my functions, and that's probably a good thing. And we will write this function quickly as well. So we have create ball, also pass canvas into it. And here we will not need a list. We only have one ball. So we will just write ball equals canvas create oval, if I'm not mistaken. Please watch my spelling and tell me of any mistakes that you see. So create oval, and in oval, it's also, if I remember correctly, it's also the top left and the bottom right, so it's not the center of the ball. In this case, let's start at the middle of the screen. In our case, the middle of the screen is obviously canvas width divided by 2 and canvas height divided by 2. But in order to, at the moment, it would not be centered. The center point would actually be the top left corner of the ball. And let me give me a second. It's supposed to be, we need 4 coordinates, and then we need the color. Well, we don't need the color because it's black by default, but I do need 2 more coordinates. And in our case, if I add, for instance, ball radius here, and I add ball radius here, we will not get the correct result. It will closely resemble the correct result, but it will not be one, because if we watch closely, we will see that it's not centered. It's actually a bit to the right of the center, because we just gave this as the center, the top left coordinate. And it's actually smaller than it's supposed to be, because we, instead of the diameter, we use the radius. So it has to be twice the size and 4 times the volume, I would guess. Not the volume, but the area. So in order to fix this, in order to make this all good, we need to subtract the ball radius here minus ball radius to move it slightly more to the top and to the left. And here we would need to add the ball radius. I think this would work, because then we would have the full diameter printed on screen. Let's try this again. There we go. Now we have a normal sized ball, and you can see that it's centered as opposed to the previous one. So horizontally, horizontally it's obviously centered. It's easy to see. Vertically, it's a bit harder to judge whether it's smaller or larger, but it seems to me like this distance is about the same as this distance, so it seems to look good. So okay, we have.
Yes, sorry to interrupt. We can judge it by increasing the diameter.
By the what?
Ball
Sorry,
diameter. By increasing the ball diameter.
right. Yeah,
Length.
we could do that, and then we would see. But yeah, I sort of trust the math here. I think it's correct. So we have the ball, but now, as it says, the interesting part is actually to get it to move and bounce. So let's think of how we can move it. And in order to move it, we need to change the coordinates of the ball. And if you remember the previous time we had when we did baby snake, we did the ball, the snake's direction, and I used a list of two values, and those two values showed in which direction the snake was moving. We are going to do the same with the ball, with the only difference being that unlike the snake, which moved orthogonally, either vertically or horizontally, our ball is always moving in two directions at the same time, so it's diagonal. And here it will be a bit easier to use, more reasonable to use such a list. So I will call this, let's call it ball direction. And ball direction will be, at the beginning, it will be always going down. So the second value will be 1. But the first one will be random. It will either be going left or right. In order to get a random value, I could use random choice. Choice is a function which allows me to select a random value from a list. In my case, those two values will be -1 and 1. So it will randomly either be -1 or 1 each time I launch the program. That would be the starting direction that the ball is moving. Now, each time the game loop iterates, the ball will move in some direction, and I'm just thinking of, so here the proposal is to move it by 10 pixels each time. We can actually change this. We can move it by 1 pixel. The question is how much of a delay will be between each frame of the game. So the speed of the game will be determined by two things. It will be determined by the delay itself, and it will be determined by how many pixels the ball moves in between delays. So you can increase the speed by increasing both and decrease speed by decreasing both. Let's, for now, we could actually probably even do the speed here. Let's, I'm just thinking how to do it better through a constant. Let's call it speed. I think speed here is a good way. For instance, we could say the speed is 10, so it means 10 pixels per iteration. And so now your ball direction is not going to be -1 and 1, it's going to be minus speed and speed. And each time you want to change it, you just change the constant, and you will have a different speed in your game. So now inside the main function, once we have all the bricks, once we have the ball, we need to actually set up the loop. And in our case, the idea is, the question is, what would be the condition for the game to end? Because obviously we can make it an infinite loop, so it goes over and over and over again. But in a real game, we would need a condition where, when does the game end? And in a real game, it would be either all the blocks being cleared, so the list of blocks becoming empty, or if you have your 3 lives, you lose all of your 3 lives, the game ends. For now, I propose writing while true, so it's an infinite loop, so we can watch the ball bounce around infinitely before we will stop it ourselves. The brackets inside the ball direction, you mean which brackets? Because there are several brackets, and so here, the idea is that, okay, sure, I'll do both. The idea is that ball direction is a list of two values. These values correspond to the horizontal speed and the vertical speed. So we store them separately. Which direction and at what velocity you're moving horizontally, well, the ball, and which direction it's moving vertically. So this one is going to be the first value, and this one is going to be the second value at the beginning of the game. So the question is now, what does this do? The random choice function takes this as an argument. It takes a list of values, and then it selects one of these values randomly. So in our case, it will either select minus speed or it will be select speed. If it selects minus speed, our ball will be moving to the left and down. If it selects randomly speed, it will be moving to the right and down. So both times it will be moving down for certain, but whether it's left or right, it's going to be 50-50. And Richard, yes, you can put functions in lists. Like this is a function call, so whatever is inside, parentheses gets priority, just like in math. So this will be evaluated first, and then the result of that function call, whatever the function returns, will actually be saved in your list. I mean, I could have done it differently. I could have done like, horizontal speed equals this, and then put here horizontal speed. But if I have horizontal speed here and horizontal speed here, once again, it's like an algebra. You can, I'm not sure what's the correct word in English. You can, get rid of both and just place this stuff here. What do you call this action in English? How do you say it? What do you do with the repeating values? Simplify. Okay, simplify. It's actually that simple. It's just simplify. All right, simplify sounds good. So now let's work with infinite loop. So inside this loop, we're going to be moving the ball. What does that mean? How do we move the ball? We would need to change its coordinate. And there are two ways of changing the coordinates. You can use move to, and you can use move. And out of these two, this one is easier to do because we already have, by how much we need to change. We already have this sort of speeds here. I would actually even call it maybe not ball direction even. It's sort of more like ball speed. And now, or even ball speeds, because we have both horizontal and vertical. And now I'm thinking maybe it's not speed, maybe it's velocity. But anyway, so let's move it. Let's go canvas move. The object is obviously the ball. Tell me, this is a question to you guys and gals. What is the value I need to put here instead of change x? What do I put here?
You need to put the new coordinates that you want to move it to, right?
No, because I'm using move. If I
Oh.
were to use move to, I would need to put in the coordinates. But in move, you just put the change.
Oh, so 10?
Yes, but where do we get this 10 from?
The speed?
Yeah,
The speed.
because we have this number here in the variable ball speeds. And the horizontal one, which would be at which index? Like at the moment, this is a list of two values.
0.
Yeah, the horizontal one is going to be 0, and the vertical one, then
1.
1. So that you understand better, for instance, I could have this list would have something like 10 minus 10. This would mean that it's moving to the left. No, sorry, to the right, because it's increasing in the x coordinate, and it's moving up because it's decreasing the y coordinate. So in our case, at the beginning of the game, it's always increasing the y coordinate is going down, and here it's either going left or right, depending on, chance.
Alex, can I ask you a question? In that canvas,
Sure.
move the ball speed in the x direction. Why is it 0?
Because once again, this is 0. This is the first value which, well, I mean, it's my choice. I made it the first one. Because for me, x goes before y. So this one is responsible for x. This one is responsible for y.
I know that, but I don't know why it would return you 0 as opposed to because if you're using random choice, doesn't it return
This
you?
is the index. This is the index.
Oh, okay.
Index
Well-
0 and the index 1.
Well, okay. And so if it has the random choice as an index, why wouldn't it return you 1? Why would it return 0?
It's not returning 0. It's returning whatever is stored at index 0. And this is returning whatever is stored at index 1. So once again, let me for instance, let's say that random selected minus speed right here. It randomly selected minus speed. Then my list ball speeds would look like this. It would have minus 10, comma 10. So I would have a list of 2 values. The index of this value is 0. The index of this value is 1. And when I do this, I get this value. When I do this, I get this value.
Okay. All right. Thanks.
Yeah, clear. Or are you? If you're still unsure, please tell me. I can.
It's fine.
Okay.
So Alex, I have a question.
Shoot.
I really like the way you're going about this. It's differently. I'm sort of inferring where you're going. But what I ended up doing was creating the ball and the paddle in the same helper function
Okay.
and putting them all in the same while loop.
Okay.
What I did not like about that, and I wonder if you're doing it in a better way, is that by defining them separately, I'm hoping you're going in a direction where you can make the paddle speed and delay different from the ball speed and the ball delay.
I would be able to make the speed of the paddle different, although I mean, since we're controlling it with the mouse, it really depends on the speed of the mouse. It's something beyond our control because, as fast as you move the mouse, it will work. But for instance, if we were to control the paddle with the keyboard, I could have a different speed for the paddle and the ball.
Okay, so you could have a different velocity for the,
Sure.
and it could move differently. I mean, you can move your mouse as fast as you want to, but
Right.
yeah. Anyway, so it'll be interesting to see where you go because I think you're going to define a separate helper function for the paddle, and you're not going to create them together is the way you're going, right?
Yeah, I mean, I could have done it in one function and then returned both the ball and the paddle.
Yeah,
but since they are very separate and very different objects in terms of readability of the code, I simply prefer to split them into different helper functions because they're different things.
I like your way of doing it better.
Because if I had, for instance, in the original Arkanoid, you could have at a certain point like 3 balls flying around. And then you would use the same function. You could actually pass the arguments, the number of balls you want to create. And that would sort of sit well with me. But different objects, yeah, I think warrant different helper functions. So we move the ball. And now we just need to do a delay. I think we have time already imported. Yeah, so we'll do time sleep and we will have some sort of delay. I will also set it up as a constant. And returning back to your question, the delay would still be the same for all objects because it will be used in the main function, which puts everything together. So let's say the delay for now is, 1/10 of a second. And I think this should be enough to get our ball moving, but let's check unless I forgot something, which... Okay, there we go. So this one is going bottom right. Once again, bottom right. This one is going bottom left. So we more or less have random... you see, we have 3 and 3. So it seems like it's not a weighted coin. But now the next problem is, why is our ball going out of bounds? That's not the way it's supposed to be. We need to bounce. And we need to bounce whenever we hit, one of the walls, at least for now. Let's say that we can hit the top wall, the bottom wall, the left wall, and the right wall. Obviously, in a real game, we would take out the bottom wall because that would mean losing the life. So let's now make an infinitely bouncing ball. So when we move the ball, the next thing that we want to check is whether the ball is somewhere near one of the borders. In order to do that, we need to check the coordinate of the ball, and in certain conditions, we would change the relevant direction. So if it hits the left or the right wall, we would change the horizontal speed to the opposite. If it hits the top or the bottom wall, we would change the vertical speed to the opposite, to the direct opposite. So after we move the ball, we will do a check. And I'm thinking whether this is whether this would be, yeah. I think I'll just do a separate function here, which does the job. So let's call it check collision, check wall collision. Like collision, there we go. And in order to do this, the arguments that we need will be, I don't think we need the canvas, because we're not going to be drawing anything. We're just going to be changing the direction. So I would need the ball itself, because the ball object contains its coordinates. And I would need the speeds, the ball speeds, because that's what I'm going to change. And yeah, I think this is enough. So now let's create the relevant helper function. This one is going to be called check wall collisions. There you go. And it will take... Someone is yawning so loudly that I want to yawn myself. I'm sort of going, oh, it's so late here. So ball speeds. So the check that we're going to perform, let's first go with the x coordinate. We're gonna say if, and I need a reminder, can someone help me out? How do we get the x coordinate of the ball? Because I know there is some sort of function. Is it get x or get top x or get top left? What's it called? I don't remember.
Get left x.
Get. Not get mouse, that's not the one. Okay, it's get left x, for instance. Get left x works for me. And get left x probably returns 2 coordinates. So it's probably going to be a tuple of 2 values. The first one is going to be x, the second one is going to be y. So let's just do that. We're gonna do ball x, ball y equal ball dot get left x. No, not like this. Canvas. We do need canvas. We can't. Yeah, this doesn't work without canvas because it works differently. So we do need to pass canvas here. So this is going back to the question of information flow. we need to pass canvas to this function because we need to use canvas here. So that's why we can't work without it. And this function returns a tuple. So a tuple, I will remind you, is like a list, but in parentheses. So for instance, it gives us the coordinates 120 to 170. And 120 will be saved to ball X, 170 will be saved to ball Y. And now we can do check. So basically our check is going to be the following.
Sorry to interrupt. We have to receive the parameter of canvas. Check wall condition.
Yep.
Yeah.
Thank you. Good. And let me have a quick look at the chat because I see I'm missing some. Should be muted. Tuple, not a list. So we are actually getting a tuple. Line 58. Okay, sure. Let me walk you through line 58 again. So we have this method which is called getLeft. Hold on, sorry. No, it doesn't return a tuple. Is there actually one which returns a tuple, or I'm probably mixing up? Or do we have chords? Someone wrote chords, and I think, yeah, this would be a lot more helpful. We could do list of coordinates of the object. This is formatted. Yes, this is the one we need. So the chords method here returns a list of two values. The first value is the left X, and the second value is the top Y. And then these two values, since here I'm saying, save them into two variables, the first value is going to be saved in the first variable, and the second one is going to be saved in the second variable. I didn't need to do this. I could have just created a variable called like coordinates, and then in that coordinates I would save the entire list. But this sort of makes it a bit easier to work with the specific coordinates I need. So Mika, let me know whether this clears it up or if you still have questions on how this works. So now we have ball X, and if ball X is suddenly less or equal to 0, so this means that the ball is at the leftmost side of our gaming field. Or if ball X, and now here's a question to you guys and girls, what do we need to write here to make sure that it does not fly off the right side of the screen?
Width.
No, well, canvas width, but
Yes,
is this enough? Yes, we need to use the size of the ball as well, for the simple reason because otherwise it will go behind the boundary until the left X is at the edge. So your ball will sort of disappear for a while off the screen and then come bouncing back. In order for this not to happen, we need to subtract, and it's actually the ball size, which in our case it's given to us as the radius, but we need to use the diameter, so the entire ball. So it's going to be ball radius multiplied by 2. And in either of these two cases, the action is going to be the same. And you would maybe tell me, but it's not, Alex. It's going the other, like here it's going like this direction, here it's going this direction. It's different. But it's not, for the simple reason that you would go ball speeds 0, you multiply it by -1. And you want multiply it by -1, you simply change the direction. You change the vector. The velocity remains the same, but the vector is now 180 degrees in the opposite direction. Yeah, so it reverses it. Tatiana, you're asking why multiplied by 2? Because we have the radius. The radius is half of the ball. So if I need the diameter, I need to multiply it by 2 so that it's the entire ball, because otherwise you would have the center of the ball ricochet off the wall, and we need the other side of the ball to ricochet. And the same, we will do the same thing. I can actually copy and paste here with a couple of changes. And actually this one as well, for the y coordinate. So it will be if ball y is less than or equal than 0, or ball y is more than canvas height minus ball radius multiplied by 2. We will reverse the first index. And I think this is it. The important thing here, guys, the important thing to know here is this action does not have to return anything. The reason why it does not have to return anything, because we're changing a list. And a list, if you remember from one of the lectures which spoke about mutable and immutable data types, a list is a mutable data type, which means that if you change it in one place, all of the variables pointing to that list will be pointing to the changed list. So since I'm changing the list here, it will also be changed for the bricks variable which I have inside of main. So I do not have to, I could have written it like this. It would not have made a difference if I had done this and this. But this would be redundant because it would return, it would return the same reference, exactly. So we don't need to do this. And this is a bit of a difficult thing for newbies to grasp when you're you go like, why do you have different data types? Why some of them are mutable and some of them are immutable? And the reason for this is because large data types like lists often take up so much memory. For instance, if you want to load in an Excel file which has 10,000 files, 10,000 lines, you do not want to create a copy of that value each time you call a function with it, because your memory will just become a trash bin. So it's passed directly sort of as a value which can be changed inside that function. So let's see whether this actually works, because this is all nice until we actually see working program. Let's go. Okay, so the ball is moving. I don't think it's working. For some reason, I don't think it's working. So let's see what the reason for that could be. So this was actually this one. Ball speeds multiplied by -1. Create rectangle. Did I do the correct one here? Brick ball speeds. Ball speeds. Yeah. Oh wait. Hold on. I did not need to do. Did I? 1 second. So check wall collision. Canvas ball speeds. Let's do some simple debugging to see what the problem might be. Let's print the ball coordinates. Chords ball, and let's see what's going on with our directions. If someone has any idea why this is not working, feel free to shout out. I do not have any idea for the moment. So it's going, it's going, it's going, it's gone. Why is it gone? Stop. Stop hammer time. So it goes to 0, 530, and then sort of it does not change. Why doesn't it change? Why does
on line number 61, I think it should be times equal -1.
Okay, thank you. Thank you very much. That was a very simple explanation for this. Is why I should not be doing this in the evening or at night. I'm making stupid mistakes, but good thing I have you guys. Thank you, Priscilla. So now, as we can see, we fixed the silly mistake, and everything seems to be bouncing around just fine. And if we, for instance, make the delay smaller, let's make it like 1/50th of a second. you'll see that the speed is higher. But then we could actually make the movement of the ball more fluid by reducing the speed to 1 pixel per iteration. And you will see that it's very slow, but now it's very smooth. So it's actually moving pixel by pixel. You can see that the speed for us now is 1 or minus 1 instead of what we had before. So we can speed it up. We can make this even, even faster. The only question is, whether the site is going to start, like whether Google Chrome can support this. I don't think, not really. You see, it's still, I don't think the delay works at this specific speed. It's too much. It's too quick for Google Chrome and for this specific IDE. So let's go back to what we had initially. Let's have the speed of 10. I think it works fine for us. Now there's a quick one. Good. So I think now we are done. Are we done with number 2? Was that what we're supposed to do at number 2? Ignore this, ignore that. Yeah. So now the next thing we actually need to do is add the paddle. And like we discussed with Nate, we are going to do a separate function for this. It's going to be called, obviously, create paddle. No, nothing original from me here. And it's going to be almost the same as with the ball, but instead of the oval, we're going to be obviously creating a paddle, a rectangle. So canvas create rect. So let's think about this for a while. What is the top X of our paddle if we want the paddle to go at the bottom of the screen? What's the first argument we need to pass? Rectangle. Okay, thank you. Yes, this is very difficult for me. It's like balancing two different foreign languages in your head. Well, for instance, I studied Italian and German at the same time, and I always mixed up the articles, speaking Italian with German or German with Italian. It's the same with two different libraries which do the same thing. So the first argument, what's the left X? It's not the top. What's the left X of our paddle? If we want it to be at the center of the screen at the beginning of the game. Yes, we need to take the half of the canvas and subtract half of the paddle, or we can do, like the canvas width minus the paddle, what is it, paddle width, and divide them by 2. I would actually do this as, just easier to read. Paddle X would be canvas width minus paddle width divided by 2, and paddle Y, the top Y. Ich bin ein Berliner. That's the extent of my German. Yeah, I understand. That's a famous phrase. If I remember correctly, it was the John F. Kennedy saying, Ich bin Berliner. So what's the Y? Canvas height minus 30. Well, yeah, in our case, it's not minus 30 because we actually have also a variable, a constant for this. We have actually paddle height, and our paddle height is not 30, it's actually 15. So here we go with canvas height minus paddle height. No need to divide by 2.
Wait, Alex, can I ask you a question about that Y?
Sure.
Because I thought what they wanted was there's a gap from the bottom and then there's the paddle height. And so I thought that I might have just like hallucinated or something.
No, it's not. I'm looking at it right now. It's definitely not your hallucination. I think it was more me remembering the original game and not even, you know, registering that there is a hole here. Because in terms, they gave Y at the top, really? Paddle Y. Oh, okay. They actually, this one I missed completely.
Yeah.
Okay, thank you, Richard. Yeah, I see it here. So that's where the -30 comes from. Okay, we can just use pedal Y. Thank you. We don't even need to do this. So then here we would have pedal X, and we have pedal Y, I guess. And then we have pedal X plus pedal width. And we have pedal Y plus, I guess, pedal height. And here we need to return it. We need to return the created object. And here we are saving it to the variable pedal. Okay, let's take a look at what we have now. Run again. Okay, there we go. So we do have a pedal at a certain distance from the bottom wall. Of course, it's not moving at the moment, but at least we have it here. Good. Now, what's the next thing we need to do with the pedal? We need for it to track the X coordinate of the mouse. So basically, we don't care what's the Y coordinate of the mouse. We just care for the horizontal coordinate. The paddle, or more specifically in our case, the center of the paddle, has to follow the mouse. So it shouldn't be like this, because initially when I did it, like my pedal was, you know, the top, the left side of the pedal was tied to the mouse, but I need the center of the pedal to be tied to the mouse. And another thing we need to think about is that if the pedal hits either the left wall or the right wall, it does not go past the wall. So it then sticks to the wall. It does not break through it. So these are two things we need to get to have in mind. Remember, we have this method which is called getMouseX, which returns the current X coordinate of the mouse. So we're going to use it. Here after, or probably let's do the paddle move before the wall move, although it does not matter. So here we will move the paddle. And we're gonna use move 2. So here, move 2 is a lot better because we will give the specific coordinate where it needs to end up. And the X coordinate will change. Here, the Y coordinate will never change. So the Y coordinate is always going to be paddle Y. So here we can call canvas dot get mouse X. And this is not the coordinate we're looking for. We do not want, I would actually move this into a separate function because we also need to check whether it's hitting the left or the right wall. So let's do a function which is going to be called move pedal, and inside we'll pass canvas and we'll pass the pedal itself. And this one is going to be somewhere here. Def move pedal canvas pedal as parameters. And before we move, we need to make some checks. We'll do mouse X equals this. And then we'll do the following. The first check, if the left side is trying to go past 0, we will set it to 0. So that the pedal would not be able to break through the left wall. But since we want the sort of the center of the mouse to be responsible. We want the cursor of the mouse to be responsible for the center of the paddle. We need to make a bit of a subtract something here. So we say if the coordinate of the mouse minus half the paddle width is less than 0, we will make this coordinate paddle width divided by 2. So we will never go past the left side, and the same should apply for the right side. If mouse x plus, I think, paddle width divided by 2 is more than the canvas width, so we're trying to go past the right wall, we will keep mouse x at canvas width minus half of paddle width. We'll have to check this right now because I'm not sure that I'm calculating this correctly, but for the moment it sort of looks legit. And now,
good question. Why are you doing getting just the integer part of the division? Why not do it for exactly,
because it's not going to work exactly in terms of pixels because there are no floating point pixels. It would still round it up to something, and I prefer to have a very specific result instead of, saying like I have no idea what the result is going to be because it's, floating point division. So that's the reason why I always use integer division to be very certain that I have an integer in there. And now we need to move the paddle to, I guess, to mouse X. I think now we have what we need. Do we need to return anything? We don't, because paddle is an object and objects are mutable. So this is not an integer, this is not a list, this is an object of a certain paddle class. In our case, it's the rectangle class, and it's immutable. All objects are mutable. So let's see whether this actually works, because it's all fun and games until Alex presses run and then something ugly starts happening. So, okay, but still, as you can see, I did not solve the problem that I wanted to solve, because at the moment, my paddle follows, it's not at the center. So that's the reason for that is because in move paddle, here it should not be just mouse X. Here the coordinate should be mouse X minus half of the paddle width. Let's try this again. Okay, so now you can see that the paddle is following the cursor through its center, so it's always the center of the paddle for me. But now let's check the left and the right wall whether my calculations were correct. So as you can see here, I cannot go past the wall. It does not break the wall, which is good. And here, it also fails to sort of break the wall. So my conditions are correct. I now have a pedal which will not go past the game board, and it's almost like it's working. Yay! But then, yeah, it's not going to be. Yeah. Okay, so are we done? I think we're done with number 3. So now it's the most difficult part. And to give you a heads up, guys, I'm probably going to, we have about 25 minutes left, so I'm comfortable doing 2 hours, but then it's going to be midnight, and if I'm waking up at 5 o'clock to have a flight. Yeah, I think we should be able to do collisions in 25 minutes. Let me check the chat. All objects are mutable or mutable, or objects are mutable. When I say objects, no, this is not a very correct statement, because actually in Python, even integers are objects. But in this case, yeah, specifically canvas objects are mutable. But even if you do another objects using classes, which we have not, gone through in code in place, and actually classes are a topic which is discussed later, then they would all be mutable in this sense. So the question, yes, if an object is composed of immutable values like integers, floats, etc., the object itself would still be mutable. It's the same as with a list. You could have a list of integers. The list itself would be mutable, even though it contains immutable values. The same applies to objects of specific classes. I'm not sure. What do you mean, Adina, where you say "Oh my God"? I'm not sure what the OMG is about. Oh, no problem. I mean, I do not mind. I do this because I enjoy this. So it's not a question of me struggling. It's a question that I understand that I will have 5 hours of sleep, and I would like to get some sleep. But yeah, no problem. So now let's take the collisions. Let's look at the collisions. So what we need. Hold on. Though, yeah, at the moment we're not. The paddle does not work for now. This will be done later. The finishing touches, I guess. So now the collisions. There is a function. Remember, I think we used it during Snake, which is called find overlapping. And the idea behind the function is that you define a set of coordinates like a rectangle, and then you check how many objects intersect or overlap with that specific rectangle. And what we could do, we could take the coordinates of our ball and see whether the rectangle which surrounds that ball intersects with any other objects. And what objects do we have? We only have 2 different types of objects besides the ball. We have the bricks and we have the paddle. And those are the 2 things we're going to check for collisions, whether we're colliding with the paddle or we're colliding with one of the bricks. And if there is no collision, then this find overlapping method would return a list of only one object, and that one object will be the ball itself, because obviously the ball is always going to be inside the rectangle which surrounds that ball. But as soon as we have more than one item in the list, that means that it's intersecting with something. And what we'll probably do is we will check whether that's a paddle. And if it is a paddle, we're going to change the vertical direction to the opposite. Otherwise, if it's not a paddle, it means it's a brick. There is nothing else. And we will destroy that brick. So that's basically what we're going to do, right? We're going to find overlap if there is overlap, which means there is more than one object value in that list. We'll check if it's the paddle. If it is, we change direction. If it's not, we destroy that object. And that's the basic logic. So let's now turn this into code. It's easier said than done. So let's think where we're going to do this. So we move the paddle, we move the ball, we check for collisions. So this is probably a good place to see whether we hit something. So if we have check wall collisions, how about we do check Nate, I see you're speaking. I can't hear you because your mic is off, and I'm sort of saying Nate is probably saying something smart.
I call them colliders.
Colliders, check colliders. Yeah, let's do that. Check colliders works for me. So we would need the canvas. We cannot work without the canvas. We would need the ball. We would need the paddle, and we would obviously need the bricks. We would need everything. And let's do it here. We say check colliders. We have canvas. We have, what's the order? the order is very important because it has to be the same order, because otherwise you're going to be screwed. Ball, paddle, bricks. Ball, paddle, bricks. Ball, paddle. It sounds like a child game. Ball, paddle, bricks. Rock, paper, scissors. Ball, paddle, bricks. Ball destroys the paddle. Paddle destroys the bricks. Bricks destroy the canvas. So what we're going to do here is first we're going to find the overlap. So we will have, just like it's offered here, we'll have colliders equals canvas find overlapping. And instead of like specific coordinates here, we would need the coordinates of the ball. In order to get the coordinates of the ball, we would have like ball X, ball Y. We know that we can get it. We already did this once through chords. I think like this. And now the rectangle that we need starts with ball X, ball Y. That's the top left corner, and the bottom right corner is going to be ball X plus ball radius multiplied by 2, because we need the diameter. And the bottom one will be ball Y plus ball radius. I'm already thinking that I would need a constant which is called ball diameter and just take ball radius and multiply it by 2 instead of writing this every time. But yeah, let's stick with this. So now we have colliders. And the question that we're asking, if the length of those colliders is more than 1. Because if it's 1, we just have the ball. We only have overlap with the ball. But if it's more than 1, there is something else in there beside the ball. And the first thing we're going to check if the paddle is in colliders. So this syntax checks if the object which is stored under paddle is actually somewhere in the list of objects that we're intersecting. And if it is, there's only one thing we need to do. We need to change the vertical speed. There is a catch here, of course, because this is the place where if the ball hits the side of the paddle, it will start behaving very strangely. So at the moment, I'm not going to do this, but in a real game, you would also need to check whether it's hitting the top or the side. So you'd have to check compare both the X coordinates and the Y coordinates of the ball and the paddle in order to make sure, but I think Nate has an idea.
Yeah, I mean, the way to handle it is just to do the minus of the absolute value for the direction of the ball when it collides with the paddle. That makes it bounce off of it no matter where it hits.
Could you repeat that? I don't think my brain is...
Rather than changing the direction of the ball when it hits the paddle to minus the direction, minus the direction per iteration, okay, you do minus the absolute value.
Oh, okay, you always do minus.
Yeah, and then it's always minus. If it hits the side, it flies up. If it hits the corner, it goes up.
Still flies up. It always flies up.
Doesn't get stuck on the paddle.
Right. I think that's an excellent idea. Let's go with that. Love it. So we go ball speed 1. We don't have ball speeds. We need to pass ball speeds here. That's what I missed. I passed everything. Yeah, I forgot about the most important one. Where is this one? Here it is, ball speeds. So this is information flow, ladies and gentlemen. This is how we do it. This is how we rock ball speeds. And in this case, I love the idea that we simply say ball speeds 1. So the vertical speed is equals to minus the absolute value of ball speeds 1. Did I get that correctly, Nate? So we get the absolute value and then add minus to it, the unary minus. And I can't hear you again because the mic is turned off.
That should work. So
it should work. I don't remember whether we discussed this function in code and place or not, but basically this function returns the absolute value. If it's positive, it stays positive. If it's negative, you still get positive.
Yeah,
So,
and by the way, I was puzzling why it called the math library. And I think that's why, because I anticipated you might have to do that.
but you don't, apps is a basic function. It's not in the math module.
Oh, it's not on the math module? Oh,
No,
okay.
no, it's not, and round is not in the math module. So these are like one of the built-in functions.
Got it.
Okay, so I think we're actually done with the pedal. Let's maybe see whether that works or we forgot something. Let's check. There we go. Did that work? Did it actually hit the pedal? Yeah, it hit the pedal. So we are not hitting the bottom anymore. But we also need to work with the bricks. So if we have a length of colliders more than 1, and this condition fails, so this condition is false, it automatically means that we hit one of the bricks. So here we will do an else, and yes, destruct, demolish, destroy the bricks, that's where we're going to do it. And one of the interesting questions is what happens if we hit multiple bricks at the same time, because theoretically the ball could be like this and it's like touching like 3 or 4 bricks. Well, not 3 or 4, but it could easily touch 2 bricks at the same time because it's obviously larger than the gap. Like, what do we do in this situation? And according to the rules written here, we just destroy one of those bricks and bounce off. So the speed here, I mean, here we would need to do it differently. Here we would have to here.
Alex, I would not do an absolute value for the balls.
No, it's not going to be absolute value here. Obviously, it's going to be like this. I'm just thinking that theoretically, if you hit the brick on the side, you would actually change the x direction, the x speed and not the y speed. And this is something that needs, let's keep it like this. Let's simplify it for now. But this is something, yeah, that needs a bit of thinking. So once again, if we hit one of the bricks, obviously the speed is going to change to the opposite, because we could theoretically hit a brick from the top, and then we would need to go up. And the second thing, the brick. How do we destroy the brick? In this case, we would work this by index. And the question here would be, at what index is the ball located? And this is easy to guess, because if we look at the order in which we created objects, we would see that we first created the bricks and then we created the ball. And each of these objects will have a number attached to it. You would have like object 1, or was it, I don't remember, like
0. It starts with 0.
Yes, so I'm trying to remember the word that is used to describe it. Shape, I think it's shape.
Shape
it would be shape 0, shape 1, shape 2, and the ball would be the last shape in this situation because bricks were created earlier. So we can safely delete whatever is at index 0, because that's gonna be one of the bricks that the ball hit, and not the ball itself. And in order to do this, we simply need to use the delete. Yeah, it would be canvas delete, and whatever is located in the bricks list at 0. I think this should do it. But let's check. Let's check whether I'm not being crazy. Oh no, I definitely did something different. This is not the way it's supposed to be. Nope, not working for now. Okay, why would that not work? Why did it first destroy this one? Let me try again. Oh, sorry.
You want to delete colliders.
Right. Yeah, I realized that at the same time you said it. I don't need to delete bricks. I need to delete. Here's the, yeah, it's a bit more difficult. I need to take the value which is at the 0th index of colliders. And then I need to remove from bricks. I will use remove because remember, we have pop, which removes by index, and we have remove, which removes by value. And I will actually use remove to remove this object from the bricks list. And this should, I'm just thinking right now, would that actually delete it or not? Not sure, let's check. Maybe this is the wrong, maybe I'm doing this too difficult. Let's see. Yeah, no, that's not gonna work. So we probably still need to use delete. Oh, hold on, I mixed in two things. Yeah, I'm being a bit silly here. Let me comment this out. Let me first try doing it. I think this is going to be the wrong way to do it, but I just want to experiment. Yeah, it's not working, of course. So forget about this idea. Nice idea, but it does not work. So then we would need to delete colliders 0. Yeah, probably
That should work.
Yeah, it should work. But it doesn't.
Can you print what's in your list of overlap?
Yeah, I think I would like to print that. That's true. Oh, I'm still printing out the coordinates. Where is that?
Wasn't that commented out?
Sorry, one more time. Oh, it's commented. Duh. Thank you. I mean, it's commented out, and I'm surprised that it's not working.
Where was it commented out?
Yeah, I had a comment here.
Oh.
So that sort of explains it. But now it gives me close parentheses 1, 2. Yeah, this one is extra. No need for this one. That's what you get when you code it. Midnight. Okay, there we go. There we go. It's alive. It's alive. But do you know, guys, I mean, what's your guess? What will happen if I comment line 86 out? And I'm looking at the chat right now. Can we use method remove from the list as an alternative? Yes, Svetlana, this is what I tried to do, and you see it didn't work because it does not, it sort of removed the object from the list, but it did not destroy the object itself. So that's, I wanted to try it out, but I mean, logically, yeah, I thought that it wouldn't work. Why is the brick collider 0? Reinhard, the reason why brick colliders is 0 is that because, like I said, when we create the object, we first create all the bricks, and only then we create the ball. So the ball will always be the last in that list of items. So 0 would always be something besides the ball, and in our case, it's always one of the bricks.
Alex, I don't see yet how you're taking care of the ball hitting 2 bricks.
I'm just taking one of them. So if it even hits 2 bricks at the same time,
you're still getting 0 impacts.
It's going to be 0 and 1, and ball is going to be on 2. And I'm sort of just randomly deleting the 0th index. So yeah, if we put the comment here, the ball will just go through all the bricks and destroy all of them. So it's gonna be like destruction derby here. Should be like. Now this is a game I like. This is a lot faster. This is a lot more dynamic. Because I hate waiting. It's such a slow game when you have to hit each and every one. And this one is like, this is my kind of game. Destroy.
Disintegrate.
Yeah. Demolish. And now there is a possibility of a situation where we would not be able to hit some bricks. This is theoretically possible because I cannot, there we go. Well, they're all done. We cannot exactly compute what are all the possible paths that the ball can take because we're always reflecting at 45 degrees and you never know, is there a sort of spot that you can't reach. So I think we are done with the story checking all the collisions. We're very close to actually getting this done. So there is a situation where if we hit the bottom wall, we need the game to be over. And this is actually pretty easy because in order to do this, we need to change this condition. Now, instead of an infinite loop where we have while true, there is no way to lose the game and end the program. We need to check whether the ball touches the bottom. So in our case, I would do two things. First, when we have check wall collision, I will remove this one. I will stop checking for the collision with the bottom of the screen. So the ball will be able to fly out of the bottom if I do this. But now I will add the condition here, and I will say that while the ball's coordinates, so it's canvas get, oh, my memory, is it get, I wonder if I can get the bottom y, or is it always top y? Probably it's always top y, plus ball radius multiplied by 2, while it's less than the canvas height, right? So why this is less, why it's still visible, we continue doing this. As soon as it's out of sight, the game is over. Let's see if this works. It does not, because I have some sort of error. What is the error? Using a method instead of calling the method. Of course, yes, I need to put the parentheses. And I need to put ball here. I died and I didn't even see it happening. Okay, so this works, and now it, so yeah, this is game over. Also, although it's not at the place that I thought it would be because, oh, right, because I myself was checking the bottom, but I want to check the top. So I will not add the ball radius here. And now the game will end after the ball completely leaves the field. And now it's stopped. So yeah, the game doesn't work anymore. So we are done with this part. What else do we have? Other
Alex,
terminating. Yeah.
Can I ask a quick question about like
Sure.
the bottom? Because the way that I wrote mine, the ball like touches the bottom and then the game ends. And so how did you get it to go down past the bottom and the game ends?
Sure. It's here in line 36. So I'm checking that the top of the ball is actually past the.
Oh, I see. Okay. Yours is like top is past. Okay. Whereas my condition had
Probably
passed
bottom.
and then equal. And so I think as soon as it touches, it just stops.
Right, because in my case, I initially did the same,
Understood.
probably that
Yeah,
you
yeah,
did something. I added the radius, and as soon as it touched, it was over. But I wanted it to fly away before the game ended, so that's the reason. The second terminating condition is actually winning the game, and in our case, winning the game means no more bricks. And this is actually a very simple condition. You could do it like this. The reason why this works is that any value evaluates to either true or false, and in case of lists, any empty list evaluates to false. Everything else is true. So I'm saying, no, it should be while bricks. It should be here while bricks. So while there is at least one value in the bricks list, the game continues. As soon as there are no values, we win the game. And we could actually here at the end, we could print out a message. We could say, if bricks, we would say you lose. Otherwise, we would say you win. because there are only two ways to get here. You either touch the bottom of the screen and then you would still have bricks and you lose. Otherwise, you got here because there are no more bricks left and you would say you win. Let's check whether that works. But that's the general logic here. Ah! Why didn't it stop now? Oh, what happened? What happened? Hold on. Okay, my mistake. My mistake. The reason that happened is because I wrote the compound condition incorrectly. I should have written here and, because we're writing the condition for continuing the loop, and the loop should continue only if both of these conditions are true. If the ball is not below the bottom line, and if there are still bricks available, we move the game. So now that I change it to and, it should work correctly. Let me get the full. So let's first try to lose. So this is the end of the game and it says you lose. And then now let's try quickly to destroy all the bricks once again, just for the sake of seeing whether we can win. And we know we can because we already done this once. So hard to control the mouse. So we just need to wait for a while because the path is already preordained. No, that's the wrong word. I did not use a correct word here. It's premeditated. No, not premeditated. What's the word? Help me out with the word.
Predetermined.
Predetermined. Thank you. 12 o'clock here. I use weird words. Preordained. Where did that come from? It's like it's a ball. It's not a priest. Hey, come on. Why are you? So here are the two. I think these are the two blocks that we cannot hit them. The last time it worked because we hit the bottom and then that changed the trajectory. But now we are in an endless loop where we cannot hit the two final blocks. I don't think it's gonna work. I don't think there is any movement. Yeah. So this game is unwinnable. This is an unwinnable state of the game, and we would actually need to do some changes. Maybe change one of the parameters. So you know what I would do? Let's do a huge ball. I want a huge ball. Let's do it like radius 50. Oh, this is gonna be good. This is a wrecking ball. Destroy everything. I wonder whether this is gonna work because it's not a given. No. Okay, we need to destroy only one more. Can we get there? Can we get? Yes. Why didn't it end? Why didn't the game end? Why didn't the game end? What's going on? Why? It still said you lose, but we destroyed all the bricks. I'm confused, which is normal. Wow. That's surprising. If bricks.
Your if is outside of the while loop.
Yeah, but that's normal because the while loop ends when the game ends, and one of two messages is supposed to.
Yeah, never mind.
But now, no, now I'm interested. I want to print bricks and see what's left in there. Because obviously something is left in there if the game doesn't say you win. So let's try this. Let's do final run with the wrecking ball and see what the reason for this is. Maybe someone is writing something in the chat right now, but I cannot see the chat at the moment, so sorry. Okay, let's now end the game and see what it says. Oh, wow. So we're definitely not doing something. Okay, I got what the problem is. We are deleting. Okay, I got it. We are deleting these shapes here from colliders, but we are not removing the value from the list of bricks. So going back to the question of whether we have to, whether we can and whether we should remove it, I think we should actually as well remove it from bricks. So we do remove and collider 0. Would that work? One more time.
Yeah, that should work.
Yeah, let's check. You know, it's a very good rule to test everything. Okay, and we know we can destroy that one on a couple of bounces. Okay, there we go. We have, you win here. We have the empty bricks, and that's why we win. So I think we nailed it. I think we have everything here. We just don't need to print the bricks here anymore. This one, yeah. Unfortunately, yeah, it's already 7 minutes past, so we're not going to do it with 3 turns. But with 3 turns, it's not that difficult. The thing with 3 turns is that you need a variable which counts your lives. So you have 3 lives, you have 2 lives, you have 1 life, and then you have 0. And then your condition for ending the game would be not the ball hitting the bottom, but 0 lives. But you would need to create another loop outside this one, because some of the things I think you would need to do again, like you would need to create the ball again, you would need to destroy the old ball and create a new ball, and you would need to no, I don't think you would need to create a new paddle. So this is something that you would need to think about with 3 lives. And I think that's actually it. That was the last one. Here it says testing. So we're not going to do any more testing right now. But let me look in the chat. Let me look at the chat. Maybe I missed something. What's red and bad for your teeth? Brick. Okay, that works. Could you share this code by email? Yes, I see that Vicky is saying that she will send a link. I will post it in the forum, but if Vicky will share it with you over email, that works as well. Remove is needed. Yes. Shall we create object of text on canvas for game over? I would do it. That's a good idea. Obviously, it's a lot better than writing something in the terminal, but it would take some time, and yeah, probably not now. I mean, if we had like half an hour more, we could do it somewhere in the center of the screen print. Either you lose or you win, depending on the condition. But I trust that you would be able to do it yourself. So yeah, I mean, I should leave something to you. Try making, changing something here, making it a bit better. Try the thing with the 3 turns so it plays until you lose your 3 lives. You could actually even do several, well, not hearts. It's difficult to draw a heart, but you could do like 3 dots which show how many lives you have. But the thing that you would need to consider then is that those would also be objects on the canvas. And you would actually have to make sure that the ball does not destroy those objects, because it would be funny if the ball hits, your lives, and those lives disappear because the ball hit it. So this is something you need to consider as well. Okay, guys, it was fun today. So thank you for joining. I think Vicky won in the terms of the number of people that joined. Though I do not know how many people joined in peak, but it was obviously more than 30. So now I owe Vicky a couple of coffees. So yeah, thanks a lot, and remember that our next session is going to be in 2 weeks, because I'm unfortunately busy in the evening. Next week I'm teaching a live workshop in Yerevan, so I will not be able to join in at the time. But yeah, we'll meet again in 2 weeks. And remember, our next topic is strings. Vicky will share the links to the problems and to the lectures so you can so that you can watch and try those problems, and we'll discuss them when we meet next. And yeah, I think that's all for today.